Okay, so far we just had a review and some more details on vocabularies, and now we'll come to our main topic for this week, which is how to query a knowledge graph. So by now you've worked a bit with Python and RDFlib on RDF graphs, and you've seen that you can traverse a graph just by going over the subject, property, and objects. So a very simple way of doing it was a loop like the one shown here. So you go through all the triples in the graph for a given subject. You leave the other two undefined, and then you get the property and the object, and you can do something with it. So that obviously works, but you can already imagine if you have a very big and complex graph, it would be very annoying to manually find the right node and traverse the graph going on from there. So it is possible to manually go through the graph, navigate to a URI and then do something, but this is not what you want to do in practice. Rather, the way you work with these knowledge graphs, if you have a complex question that you want to answer for something like the one shown here, give me the pair of resources for which there is an X, such that X is a parent of A and B is the brother of X. So essentially this queries all the uncles in a set of triples. And you can see that you can make arbitrarily complex questions that you want to have answered from the knowledge graph. So we don't want to hard code these in Python or any other language. We want to be able to ask complex queries against a graph. And for this, there is a query language called SPARQL. To understand how SPARQL works, again, let's look at the pattern that we had here. So we specified a subject. So this is a fixed URI. And then starting from this URI, we want to find all the objects connected with a certain property. And then you would go through all of these and then you can do something with them. So this is the core idea of a graph pattern, meaning a pattern that we want to apply on a graph. In this graph pattern, we have some symbols that are defined. We have some fixed URIs, and then we have symbols that are unbound. In the example here, the unbound ones were the P and the O, and the subject was defined. And then you can take this pattern and apply it to the graph. And then this is your query, and it will return the resources that match this pattern on the given graph. Now, how do you translate this Python example into a SPARQL query? This would look like this. So there is a command select, and we want to select predicates and objects that match this triple pattern. So you can see here, this is a triple, SPO. And in this triple pattern, P and O are undefined. These are variables. And the subject is defined. So again, this is a fixed URI. And then the result of the query will be all the pairs P and O that match this query in the graph. So select and where, if you ever worked with SQL, if you've taken a database course or worked with web programming, MySQL or something like this, you recognize it looks a bit similar to the SQL query language. But SQL is a query language for relational databases, meaning you query tables. And in SPARQL, we have a query language for querying graphs. Let's go back to the example we had with the bookstore. So in the bookstore, remember, we have books represented by ISBN URIs. They have authors have names, and now books also have prices. And you can see for these two books, each book has a price in two different currencies. So here's a blank note, and then we have attached to the blank note the currency and the price. So this book is €50 or 33 pounds. And this one is €60 or $78. So now we want to query the graph to get all the books together with their price. So we have three variables, the ISBN number, the price, and the currency. And now we have to come up with a query pattern that matches the graph down here. So you can see there is a ISBN number, which matches the subject. Then we have a price property, which matches the price here. And then we have a blank note, which we indicate with X here. So this is the first pattern here, subject, predicate, object. And then we combine it, that's the period, with another pattern, which is X value price. So this X, again, is our blank note. And the value of X is price. So this is the blank note, value, price. And then secondly, X is also linked to our currency. So blank note X, currency, and then the currency symbol. Now, if you run this SPARQL query against the graph given here, it will start matching. And the first triple it will return, this is the one that we select here, ISBN, price, currency, will be the one that's matched with these three patterns here. So we matched in the first pattern the ISBN number with a price, the price with the value, and the value with the currency. Are we done now? No, because this is not the only pattern that will match in the graph. Now we can take the same one and it will continue matching this ISBN number with this value and this currency. Are we done now? Well, by now you should have an idea what's happening. No, because the graph on the side here will also match the patterns given here, and you will get another return value. And then finally, the last one here will match as well. So to give you an idea of your very first SPARQL query, you're going to try out one of them. So there is a SPARQL query given here, and the knowledge graph that we want to query is the DBpedia knowledge graph. Now, to be able to run a query against the knowledge graph, you need a so-called SPARQL endpoint. And luckily for DBpedia, there is a public SPARQL endpoint that you can use. So that's the URL given here. Sometimes it's not accessible, might be down for maintenance. Not so often, but it can happen. But most of the time, you should be able to connect to this public endpoint. And well, because it's public, there are some restrictions, but for the simple queries that we're going to do on the worksheet, you can use this public SPARQL endpoint. So try it out, and then I'll see you in the next lecture segment. Good luck.